Hello everyone, welcome back to another video on my YouTube channel. Today we're discussing another problem called merge k sorted lists. This is also a part of the blind 75 list of problems. Let's look at the problem. So here we are given an array of k linked lists. That means we are given head pointers of all three linked lists in this list array, and each linked list is sorted in ascending order. So this is 1 4 5, 1 3 4 and 2 6 in the first example. And we are supposed to merge all the linked lists into one sorted linked list and return it. So in this case, the answer would be, we have two ones, then we have 2 3 4, 2 3 4, we have one more 4, and then 5, and then 6, and then null. So this is the answer we are supposed to return in this question. Now the most straightforward approach to solve this problem would be to get all the numbers from the linked list. So take all the numbers from the linked list. So 1 4 5, 1 3 4, 2 6. Create an array from these and just sort these in nlogn time. Now once this is sorted, we can just create a linked list from the sorted array, and that would give us our answer. Okay, so can we do it much better than this? Instead of taking it out in an array and then sorting it. Now if you notice, the comparisons we need to do at one point of time, for example, if we are given these k lists, there are only, you have to compare only these k numbers. So for example, let me just clear this approach and log in. So let's say we could compare all of this first numbers. So we have pointers for all of these, 1 2 and third pointer, and I find the smallest of these. So smallest of these will be 1, which can be any of these two. Let's take the first one, and I increment this pointer. Now if I could compare these three numbers, which is the smallest one now? It's again 1. I move this pointer as well. Now the smallest one is 2, and I move here. Now the smallest one is 3. I move the second pointer up front. Now the smallest one is 4. I move this to 5. Now the smallest one is still 4, and the second pointer becomes null now. Now I only have to compare these two. Smallest is 5. So this goes away. Then we have 6 and null. Now the benefit of this is that we are only doing k comparisons to find the smallest at one point of time, and we are moving across all the nodes. Now what would be the fastest way to find the smallest number in these k numbers? For example, we have these k. So in that case, what can we do? To find the smallest in these k numbers, we can use a heap or a priority queue. Heap or a priority queue. So this will give us the smallest in O of log k time. Okay. And once we have the smallest from these k, I can also insert the second number in the list. So insertion is also log of k here. Okay. So what would be the overall time complexity in this case? So I have n numbers, and I will do extract min, that is finding the smallest number, and insertions at each step. So it will be O of n log k. Okay, so we can use a heap and or a priority queue to solve this problem in O of n log k time, which is much better than O of n log n, which we were doing earlier. And what would be a space complexity? We are using a heap, so it will have at most k numbers at one time. So space complexity will be O of k. Now what would the heap actually store? Uh, it must be obvious that we'll need to store k numbers, but we'll also need the pointer to the next node to move to the next node and insert that number in the list as well. So what we can do is either insert a pair of value and a pointer, or just insert the pointer and use the pointer's value in the comparisons whenever we build the heap. So any of these approaches is fine. Here we directly use the value, or we can just use the pointer's value to get the comparison. Now let's see how we'll code this in C++. Now we are given a function called merge k lists with an input vector of type list node star called lists. Let's start by creating the priority queue which we discussed earlier. So this will be a priority queue, and the syntax for declaring is that what type of nodes will have. So let me just write the syntax real quick. So priority queue type vector of type imperator and we'll have the name here. And okay, so this should be comparator type, and we'll have path the comparator here. So this is the syntax to declare a priority queue in C++. So let's use this. So type will be list node star, and this will be a vector of list node star internally. And what will be my comparator type? Let's leave it blank for now. Let's type it comp type, and let's name the priority queue PQ, and I'll pass the comparator here. Now to construct this comparator, I'll use auto comparator and a lambda function. So what are lambda functions? Lambda functions are functions that can be assigned to variables. So in this case, this will be a function which I am assigning to the variable comp. And this function, I'll compare the list node types A and B. And this comparator should return true when A should come after B. So for example, if A is greater than B, I want A to come after B. For example, if A is 6 and B is 3 in priority queue, I want 3 to come first and then 6. So 6 should come after 3. So this should return true in that case. So I'll just compare the values of the nodes. So A value is greater than B value. So in this case, it will be true because 6 is greater than 3. So that means A will come after B. So that means this will construct a min heap. Okay. Now once I have this comparator, I want to find its type, which will be done automatically by this auto functionality in C++. And to find the type of this that C++ will find, I'll use the declare type. So decl type of comparator. And I'm also passing comparator to this priority queue. Now once we have this priority queue, things become pretty easier. I'll just iterate this list. So I less than list dot size I plus plus, and if lists I not equal to null pointer, I'll do priority queue push list size. Now once the k nodes have been pushed to the priority queue, this means the first nodes have been pushed. So in this case 1, 1 and 2. What I want to do is put a loop on the priority queue. So while priority queue doesn't become empty, keep taking out from the priority queue. So topmost node will be the minimum one. So this will be top equals to priority queue dot top. This will be the smallest one currently, and I'll just remove it from the priority queue. So that will be pq dot pop. Now, if the next node of this is not null pointer, that means I can pass it to the priority queue again. So if top next is not equal to null, so priority queue dot push tops next. And to construct the result, I'll also take a dummy node. So take dummy node is new list node. Let's give it -1 for now. And let's do cur equals to dummy. Now I'll insert these numbers that I'm removing from the priority queue to this dummy list. So cur next will be equal to top and cur equals to curs next. And at the end, I just want to return the starting of this dummy. So dummy is next. I don't want to return this -1. So return dummy. I think that should be enough to solve this question. Let's try running it. Okay. So as this is a variable which is assigned a lambda function, so this also needs to have a terminator here. Let's run it. So all three cases are working. Let's try submitting it. So as you can see, our O of nlogk solution is working. If you have any questions about this, please let me know in the comments. Thank you for watching. See you in the next video.